In this lesson, we're going to cover Big Idea 6, Standard 4 on solution stoichiometry. So first, I want to give you guys like a little roadmap or a template. So two different types of problems that you're going to see for solution stoichiometry. First, let's look at how we solve a problem if you are given grams. So we are always going to start with the given. So we're going to start with grams of the given. And our first step is going to be to divide by the molar mass of the given. So we can calculate the molar mass from our periodic table. Molar mass is always equal to 1 mole. In these problems, we are going to be given two different substances. So if we're given two different substances, we need a mole ratio. So the denominator would be blank moles of the given. Numerator would be blank moles of whatever we are solving for. So then, sometimes we can stop here. If we're solving for moles, we'll stop here. But a lot of times, you are going to be asked to either solve for volume or molarity. So step 2, we can then plug that answer into moles, and we can solve for molarity. Or if we're trying to solve for volume, liters would be equal to moles divided by molarity. So this is going to be the little roadmap that we are going to take if we are given grams. What about if you are solving for grams? If you're solving for grams, we're going to follow the same template, but now in reverse. So step number 1, we are going to solve for moles. Moles are equal to molarity times liters. Now step 2, we're going to plug it into our conversion factor, into our conversion, and we are going to solve. So now my answer to number 1 is moles. That's what I'm going to start with. I'm going to start with moles of the given. My first step would be the mole ratio. And then last step would be the molar mass. Molar mass is always equal to 1 mole. All right, so these are going to be our two templates. These should help us set up all the problems that we are going to try today. All right, first example problem. Let's say you were asked how many grams of barium chloride. Today I'll give you the molar mass. On the test you will not be given molar masses. You need to know how to calculate this. How many grams of barium chloride will be produced from 0.75 liters of 3.0 molar hydrochloric acid? And then since we have two different substances, that means we're going to need a mole ratio, so we need a balanced chemical reaction. All right, so first thing that we want to do is we want to look at this and figure out which roadmap are we going to use. So I want to know how many grams of barium chloride will be produced. We are solving for how many grams. This is what we are given. We are given 0.75 liters of 3 molar hydrochloric acid. We are solving for grams of barium chloride. All right, so let's follow our steps. I'll grab a calculator. Step number 1. Let's solve for moles. Moles are equal to the molarity times liters. So I have a 3.0 molar solution times 0.75 liters. 3 times 0.75 would give me 2.25 moles of HCl. Make sure you put in the substance. That's going to make step 2 much easier. I have 0.75 liters of 3 molar hydrochloric acid, so this is also hydrochloric acid. Step number 2, we're going to start with moles of the given. My given is HCl, and I calculated 2.25 moles of HCl. In the denominator is going to be moles of the given. Again, my given is HCl, and the way that we figured out the number of moles is by looking at our balanced chemical reaction. HCl has a coefficient of 2, so I have 2 moles HCl. In the numerator, we're going to put moles of whatever we're solving for. I'm solving for barium chloride. Again, I'm going to go to my balanced reaction. Barium chloride does not have a coefficient, so it's just going to be 1. Next step. Numerator is molar mass of what we're solving for. I'm solving for barium chloride. It has a molar mass of 208.23 grams per every 1 mole. All right, now we can plug in and solve. So again, the way that we solve these is by multiplying across the top. So 2.25 times 1 times 208.23. And then we want to divide by whatever's on the denominator. Divided by 2. I get 234, and then I get a bunch of decimal places that I don't need, because we're always going to round our answer to the appropriate number of significant figures. 0.75 has two significant figures. 3.0 has two significant figures. So my answer could only have two significant figures. So final answer, 230 grams. All right, let's do one more example using our other template. So for this problem, we were solving for grams. Let's do a problem if you are given grams. So example number 2. How many liters of 1.5 molar sodium hydroxide is needed to make 10.0 grams copper 2 hydroxide? And again, today I'll give you guys the molar masses, but make sure you know how to calculate these because you will not be given them on your exam. Again, you will be given the balanced chemical reaction. All right, so notice in this problem, we are given grams. So we're going to follow this template if you are given grams. My given is 10.0 grams copper 2 hydroxide. We are solving for how many liters of 1.5 molar sodium hydroxide is needed. So this is what we're solving for. So let's follow our roadmap. Step 1, start with grams of the given. My given is 10.0 grams copper 2 hydroxide. Step number 1, molar mass of the given will go in the denominator. My molar mass is 97.57 grams. Molar mass is always equal to 1 mole. By definition, molar mass is the mass in grams per 1 mole of a given substance. Next step. The denominator is moles of the given. This is our mole ratio step. So I'm going to look at my balanced chemical reaction. The number of moles are equal to the coefficient. No coefficient, so that means there's a 1, imaginary 1 there. Numerator will be moles of what you're solving for. We're solving for sodium hydroxide. So again, I'm going to go to my balanced reaction. Sodium hydroxide has a coefficient of 2. We're going to stop and solve. Again, we multiply across the top. 10 times 1 is 10, times 2 is 20. Divided by whatever's in the denominator, 97.57 times 1 gives me 0.204981039 moles of NaOH. Again, best practice is not to round this answer. We only want to round our answer once, and that's going to be when we get to our final answer. So now we're going to go to step 2. If I'm solving for molarity, I'm going to use this equation, molarity is equal to moles divided by liters. In this problem, I'm solving for liters. So I'm going to use my liters equation. Liters is equal to moles divided by molarity. So I'm going to take the number of moles that I just calculated, and if I look back in my problem, I was given the molarity of NaOH, 1.5 molar. So I'm going to keep this number in my calculator. This is the number of moles from step 1. I'm going to divide by the molarity. And now I'm going to round. Since 1.5 only has 2 significant figures, my answer can only have 2 significant figures. Since the next digit is 5 or above, 0.13 would round up to 0.14, and my unit would be liters. So final answer, we need 0.14 liters of sodium hydroxide.